be boring for you to make the to make the to make the server. Again, it's not very hard, especially if you already have a code in your computer that do that. If you already have some kind of pre-defined code in your computer, it's not very hard for you to make the deploy on if you again. But anyway, sometimes it can be very easy and fast just to use GitHub. It's not a server, it's just a front end, so you need to make your app as front end like. Angular does that easily. You can, in a couple of minutes, maybe even less, depend the size of your app. In this specific case, the data is coming from the web. As you see, take a while to load. I'm not sure how fast it takes, but you remember, well, it's not that long. So it's supposed, this is the app. It's on Google. I'm not sure. I think it's Google. It's Excel. I think it's like I published the. Just out of curiosity, if you are curious, I published the Excel sheet, like the spreadsheet. Then I just took the embedded code and put inside Angular. It's a very cool trick. Here's take a while to download, to upload, because specifically it's not upload from the computer, it's upload from the web using API. It taking a while anyway, but that's not the point here. You can just play around. I'll leave for you in the description of the these articles. But in our case, quite simple. It's quite simple, just for you to learn. So the first step, you have to upload the data. Maybe in the future I can use an API like this one, but I found it a bit hard to make the upload of the API using spreadsheet. This one is not spreadsheet. This one is come from public data set. It was much easier to make the upload. But in the future, I may add for you like as a Google Sheet, so you do not need to upload for your computer. But you need to get, if you want to play around but you don't have data, just get this spreadsheet here, which is a sample from a book, and download to your computer and upload to your app. Whereas when you upload, you're supposed to see the app. It's supposed to be the data set. So the second step in machine learning, which I may explain a little bit better in my book, that you should train. But for you to train, there is a very nice preoccupation for machine learning practitioner, is that you should make sure that your data know how it learns, in the sense that if I teach you how to play a song, I cannot teach you just a song that you're going to play, but the more knowledge, because our machine learning is based on our brain, it's inspired by our brain. Spiking network that Professor Katabov talked about on this channel is more close to the brain, but deep learning is not. You need to talk. Deep learning is more. The only idea that deep learning has with the brain is some kind of layers of neurons and the idea of learning. But in general, as Katabov has said nicely on our talk here, which was the last live, deep learning does not change in the size like the brain. The brain is able to change like this. The deep of deep learning is static, as Professor Katabov said nicely. But the deep of the artificial of biological network is a deep that can change, as he said. How deep, as he said, is just happening. I don't know. I thought it was very nice he said, because it's something that you control. It can be billions of neurons deep, or it can be just like a couple of clusters as well. I think it was very nice what he said. But in this case, a specific case of deep learning is not deep learning just about how much layer you have in the hidden layer. So you have feed-forward loop, which is a very classic MLP multi-layer perceptron, classical regression model. They used to say that you can make the regression of anything if you know how many neurons you should put on the hidden layers. But the problem is that the hidden layer cannot be trained if you have too much layer. But deep learning solved the problem somehow. We do have challenge with deep learning, but at least you can give them the cake, because they were able to solve one of the biggest problems of feed-forward loop, which is how to train huge amount of hidden layers. So one preoccupation of deep learning is the same preoccupation of human. You do not want people to, at least should not ask people to memorize, should ask people to learn the concept. If deep learning is the same, I mean, artificial neural network is the same, but deep learning is artificial neural network. It's a kind of artificial neural network. So you want to make sure that it was able to learn. So how can you do that? You can just present a couple of data, and then you can make sure that the network was able to learn. How can you do that? You just separate. You Yes, I will restart here because I clicked by accident, and I thought there is a bug. I mean, it's not a bug. I was unable to solve it. I will upload again. The bug is that the library I'm using is also for TensorFlow.js. They do not just have the training process; they also have the plotting. All this plotting here is for TensorFlow.js Viz, which is a library inside TensorFlow.js. It's very cool because it already give you how to plot, but I wasn't able to find it. If I did some research on the internet, if you know how to do it, let me know on the description of the video. I need to learn how to clean the graph after it's plotted. It's not clean. I think it's not clean. I don't know. But as I said before, you have to separate. Here I'm saying that 80% of the data of this data set here will be for training, 20% will be for testing. For this is randomly inside of the model is randomly. 80% will make a random, so all the time it may change the result because the randomly select 80% to be the training. It's not mandatory, but I think it's random is better. There is other way to separate as well. Some people like to separate between training, testing, and validating, like 3 groups. Like I see on my Master of Science degree, which I didn't finish because I decided to go to another Master of Science in Applied Math. But I did about almost 1 year of computational intelligence, which was a master. I was enjoying the Master of Science, but I got another opportunity, which I think was much aligned with my objective. But at the time, I remember that people used to have this kind of separation. I don't know how it's today, but they would say like you should keep like about maybe 70% to training, something like 15, 15, 15 for validation, 15 for testing. I do not remember pretty well because it was a long time ago that I used this kind of technique, but I think the difference between, because validation will be a kind of higher, a kind of I have to test how they separate. But in our specific case, you just say that training is the one that change the weight. So when that 80% of your data set will be used to change the weight. The weight, if you do not know what's the weight, a weight is essentially how the model is able to learn. Again, I'm explaining better in a book. In a book, I'm giving you more a better explanation of that. But that's essentially how it goes. Let me just use because I'm using a electronic spreadsheet. So that 80%. So you can change as much as you want here, but let me just 80%. So 80% of the data will be used for training, for changing the weight of your network, for teaching it, and 20% will be used to make sure that it was even able to learn, which means that you present the data to the network, but you're not going to train anymore. Just like you just think that the 20% is a final examination. 80%, think like this: you are in the university, so 80% of your time will be for learning the classroom, and 20% will be for making examination. Like professor give you an examination to see how you were able to learn. The idea is the same because the metaphor of machine learning comes from the brain, how the brain works. So 80% will be for teaching, 20% will be for making sure that the network was able to learn. You can play around. Since this data is very small, you do not see very strong difference between the training if you play around here. But if data set is big, I have the feeling that you should see the difference. There's another thing as well. The reason why you separate as well because you want to avoid what they call overtraining. Overtraining is when if you ask if you ask the network to learn the data precisely, it's going to learn, but it's going to memorize, and that's the problem. You do not want the network to memorize. So sometimes you have this kind of dilemma between how you make your network is able to learn the data without necessarily make it memorize, because the whole idea behind machine learning, artificial neural network, that is able to adapt to the world. It's different from say a regression and so on. So the whole idea behind artificial neural network that you should be able to make sure that it doesn't memorize. So if you split the data, as you see, you have like so you have the as you see, sorry, it's the opposite. I have to change the graph. There's a bug here. it say that the test is in blue, but it's opposite. I have to check that. I have to change that. It's wrong here, the name, but the test is in blue. Sorry, the train is in blue. So the train is the majority of the data. Then we have 3 data to be used as. See that it's random. If you do again, as you see, it's random. All the time you do, it's random. As you see. See, it's random. The bug that this in the website right now, that every time you plot here, it's not clean the data. So as you see, it's like just accumulating. No, I think it's not. I checked that, but I think there is no bug here. But I have the feeling I have to count. Let me know if you count that. It's like, no, I think it's not. I think there's no bug here. Anyway, as you see, I think the bug here is that it accumulates somehow the previous data, but I have to check that. But so in blue is the train, and here you have the train. Then you have the so here's the train, the blue, that's the train, the other will to validate. So the next step is to make to train, just train. So the train is teaching the network. I don't know how long to take, but it's supposed to be fast. I mean, at least for 1,000. Yep, it worked. Let me just hide here. Maximize. I'm going to explain what the hell is that here, but just give me a minute. I have to check to fix as well. I saw there is a body stuff here, but the point here, 1,000 is how many time. Think like this way: is how many time you teach on it, how much time you present the data to a network. So if you ask 1,000, be 1,000 times that you did the network train. As you can see, if you train again, let me see that you train again. You see that this value here is the loss. I see the loss function is how much you are make it wrong. It's how much you get it wrong. Let's do it again. As you see, 1,000 times you present the data 1,000 times, but every time you train, if the same number of interaction, it does not change too much because you are just make the same stuff. But if for example, if you go down the amount of time, the weight is supposed to increase, because instead of 1,000, as you see, instead of 1,000 you have 100. So you are presented 100 times. So you are giving things like this way. You give someone to go to the university. That you actually ask you ask someone to go to the university, but you give them 3 months to learn. Then you give them 6 months to learn. But what about if you give them 1 year? Doesn't mean that you'll be able to learn more. So what about if you ask your network to learn like 5,000 times, instead 5 times more time that you had? So you make the metaphor of the university. You are saying that the student, instead of learning 3 months, he's going to learn, for example, 2 years. For example, if you ask yourself, for example, in Brazil, the undergraduation is 5 years. In the Europe, it's 3 years. So who is right? Who is wrong? I don't know. Europe, maybe they adapt the system because since it was too much. But the same sometimes can be the same for the network. Sometimes you have a kind of point in which that your network is no longer able to learn for the data. I mean, even if you presented, even if you, as you see, 1,000, it's very small. As you're gonna see, as you see, you increase 5 times, but it decrease much more. Like increase, like it increase 5 times the amount of time you have to train, but the data was the error that the network is making when you present the test. Remember that we separate between the training and the testing. This error here is for the testing, is how much mistake you are making. Again, I'm explaining the stuff on our book. So our official that. So on our official book, that our upcoming book, I'm explaining that how it works and so on. But for now, just keep in mind that the question that I'm trying to find the best way possible, but I have the reference, I have the explanation on the book. But what about if you do not want to train a network? You do not have a way to train, or do not want to train because, yeah, as I said in the book, You should know your problem. You should know your tools. There is no magic. There is no panacea. There is no answer to everything. You should know your problem. You should know your tools. It's called no free lunch dilemma. But what about if I want to just make a random, not a very easy guess? I'm just going to make the mean. I just want to make the mean value of the data set and just say that my best guess is the mean value. As you see, it's supposed to be very fast. Not sure. Yes, I have forgotten to, because I'm still designing the tool. I have forgotten to put here. The book I'm explaining better how it works. I forgot. Yeah, I now remember, because I have to load again, because again there is a bug here. What's the bug? The bug is that I need to, because this, let me show you. I'm separating again 80%. I'm still learning how to use those libraries, so it may have some bugs here. Sometimes I have just to make a reload there, like if you go F5 dash, just do F5. I'm still to fix those bugs. I'm still trying to make it better, but just make F5. It's supposed to upload to restart everything. So I'm upload again the dataset. I'm going to make again 80% as before, plot, as you see. Remember that there is a mistake here. The blue is a train, and the other one is a test. I ask you to train the model. Here I'm not going to, let me do it again, like just to, you can play with the sandbox. That's the whole idea behind that you can train. So what I'm going to show you, that you're going to see on the graph, again, is explained on a book. On a book is explained better. I did my best to explain it in details and so on, but the point is that when you train a model, like 5,000 times, 5 times interactive learning, you take time, as you see here. You're taking time to do that. Maybe a couple of minutes. If you increase more, remember that it's not like a magic. You just increase, that's all. There is better, this example here I gave you, this one here, there's some bug here. Maybe the data set changed the address because it's not loud anymore. It's supposed to load the data set for you. But I think I may have it to see what happened. Maybe they changed the address because it was a public data set. So they changed the data set. You no longer see the data set, but it's supposed to appear in the data set automatically. It's like loading, it's supposed to appear. In the specific case of this data set, as you see, it took 5 times. But the specific case of this data set here, which I have to fix, I think I have on the article. Yes, I have here. If you come here, as you see, the training process, that's the plot, the training process. The other one you are doing, you are making the table, directly the table. But what about if you keep training, as you see? On this specific case here, because it was somehow, I don't know if you try to guess, I don't know how much hidden layer you have here, but it's supposed to have like several. These are a little bit more complex compared to the one I used, but it was able to stop learning about 20 interaction. It was much big data set, but network was much bigger. After the number 5, you just stopped. That case should stop learning, because meaningless, you're wasting your time. You may say that. This one is validation versus loss. Yes, I think this one is like the one I told you that they separate the data. But anyway, I have to check later. Because I don't remember, long time I did this simulation. The book is based on this kind of study I'm doing. But here you have the guess. Again, the same trick. The guess is one. And here you have the loss. The loss, as you see, is 80, and the loss here is 40. So that's the same thing I'm gonna ask you. It's a public data set. It's a Boston House. It's a data set that do competition for machine learning. The whole idea of data set is a free data set for a competition, so the people can teach their models and make prediction, and they can make a competition. So what about if we that's the case here, but what about if you make just just guessing. I say it was quite fast because I'm just guessing. But what about if I try to guess? So by trend, then here is by guessing. I think there's a mistake here. No, I think it's right because on the book I took more time to train, so it was longer the training process. So it was easier for you to the difference between here is not a very long but what I'm showing that even if you wanna see, it's a little bit easy to a little bit hard to see here, but on the example of the book, I gave more time to the model to learn, so it was able to. I think it was one. Here the error is 5, but I was able to ask to learn. I don't remember how many interactions, but I asked you to learn much more than one. But what's on the book you should see how regular is the mistake. So it's making mistake, but a little bit more regular. So here, but on the other hand, if you make a very fast guess, which is a mean value, it's a very fast guess. See that it's very huge because here I should check. I think there's a mistake here, but see the models are making it because the example of the book. So let me show you the book. I think it's better if I show the book. Book the upcoming book. So there is all the explanation here. I gave all the examples because you have to play around. So this is the example I did. So if you take because I did the app on the computer on a sandbox, then I'm transferring to the website. It's possible that during the transfer process there's a bug. It happened before the bugs. So you can fix the bugs, but I'm changing the app to I have to implement that thing again on make sure that the app is okay with the Miyagi Do Lab. It's not just about copy and paste. I have to redo again. But now it's easy because I already did the hard part. I just have to, like, think when you write a draft of a paper, then rewrite the article to be published. But you already know the idea behind the paper. But if you see here, here is for guessing. But if you compare, I do not know if you agree with me, but if you compare, if you try to compare to one, this one is a guessing. This one is artificial neural network. But see that the artificial network, first of all, the biggest mistake of the artificial network is 7. The biggest mistake is almost 8. So the mistake of the guess is higher. On the other hand, the mistake of the network is a little bit more regular. See how it is a little bit regular. On the other hand, the mistake of the white guess, like just mean value, is much more like much more crazy. I mean, even if you see here, it's kind of a pattern here. Let me see if I have it depends. This pattern here, as you see, it's classical in statistics. In statistics, when you see an error, and the error has this kind of pattern, you know that you didn't do your model properly. I mean, it's a very huge sign on statistics and applied statistics and applied regression that you do have something to model here, that your model is just not doing his job properly. So you do know when you have this kind of pattern here that your model is not doing his job properly. So so that's the big point. So you do know here that's not doing properly. There's something pattern here. You can model this pattern. On the other hand, if you see, I didn't do that, but you can compare it. I don't know. Yeah, but anyway, it's almost, I would say, first it's a bit more predictable. I mean, not predictable. The mistakes are not very high. They are more or less the same kind of mistake, as you see. There are a bunch here, but they are constant. I say they're kind of random. Not totally random, but still a little bit random. Remember that you can increase the amount of learning because the idea of training that should not model noise. What's noise? Noise is specific from a data set. It's not artificial network. Machine learning is all about learning how the world. I mean, learn the deep concept. I just wrote a paper inspired by Professor Casabov called Deep Learning and Deep Knowledge. So you may think that you should the whole idea of artificial network. I'm discussing that in our upcoming book. That you should somehow learn the behind, learn learn the big picture. What do him do? We humans are very bad at memory, but you are very good at memory. You are very bad at memory. You are very good at patterns and image recognition, and all the nice stuff that you can do with your brain. So I would say that it's much better to use the artificial network. But as I discussed in the book, the point is that I'm discussing that in the book better. I'm discussing that a little bit more care, a little bit more attention, because you write and rewrite. You do all the process. But the whole idea about you guess if artificial neural network is that it takes time. But you may ask yourself, how much I have to pay for a single mistake? So if I make a mistake of 10 units using a guess, if I'm using a guess, which is much faster, how much am I going to be punished for that? I mean, suppose that you have a demand for a customer. If I make a mistake about the demand, about 10, leave him without 10 items, how much that's going to cost me? I'll say a lot. If it not cost for you a kind of a fee for not delivering the product, it may still cost, like the customer may look for somebody else in the meantime. They may learn that somebody else has a better job than yours. They may lose faith on your company. So sometimes it's not a good idea to make mistakes. I mean, maybe depends on the situation, but maybe you are doing the example for the book that I used to implement this toolbox here. Not on the book has TensorFlow.js, but Angular part is mine. But the TensorFlow.js behind this app is based on a book. I'm trying to, there's a reference on our book, but I'm trying to put a reference here as well. But the whole idea behind the mod is that you should be able to make better guess. So you should always ask yourself how much you're going to pay. In the case of the book, as I was explaining before, the model, I think it was the download or the upload, I don't know, of files. So you should create an app that will be able to tell the user how long it is going to take to make the upload or the download. I do not remember. But what about that specific case? If you make a mistake by 5 minutes, if you make a mistake by, I don't know how long. I feel that you're gonna pay much less for your mistake that you pay for a mistake on a demand. I mean, if someone is, I have a student from Switzerland, and I'm help him with his PhD. He's from a company. In his specific case, he showed me some very nice examples in which his company has to make some prediction of demand. So I would never ask him to make this kind of the naive guess with average. In his specific case, he told me some kind of discussion. He has a price to pay that's not worth it. So should it take 10 minutes to process your data? Just one time. Once you process, you can just you can use as much time as you want, unless you have some very important updates. So in that specific case, you may train again. Deep learning has a concept of the transfer learning, which is something that I have not used yet, but I saw my first postdoc. I didn't use directly, but I know how it works. Essentially, you just get a pre-trained network, just train the front, for example. My first postdoc, they were using for image processing, medical image processing. So essentially, they use training from normal object. Since the process of segmentation is the same for a chair and for a window and for a dog, and for medical image, the medical images processing. The only difference that the image you are presenting is different. But anyway, you can the maybe similar case. It's not if your data set change in the future because your company has a new demand, maybe still have something to learn from the past. So you just do not have to train everything again. So this case took about 10 minutes, but if your data set is much bigger, the example I gave here, this data set here is much bigger. I don't remember exactly how much data set to have here, but I consider amount of data set. But it was converged very fast, as you see. It was very fast. Okay. The other one was 5,000. This one was able to converge in about 20 interaction. But this one is a bit more complex. The training process, I don't remember all the details, but there is a huge amount of tricks that you can use to make a training process more efficient. But you may discuss that. I'm not sure if we'll discuss that in our book, because our book is not about artificial network. I just present the example I'm just presenting the example here on a book because it's a very nice experience, because you know what's behind the scene. I think it's meaningless that I talk. I think it's meaningless that I talk a lot about learning machine, but I never show you how to use learning machine. By the way, if you are interested, if you are a Portuguese speaker, let me just show you something here. If you are a Portuguese speaker, I do happen to have a book I wrote for free. Maybe in the future I want to launch the version of this book. This book stayed for a while as one of the most downloaded book of Medium. I think, if I remember well, it stayed in the position number 3 or 4% or 5% most